A shocking incident in China. On May 1, 2025, at a factory somewhere in China, a testing routine took a terrifying turn. A video widely shared across social media shows a humanoid robot, identified as the Unitree H1, suddenly going rogue during a live test. Suspended from a construction crane for safety, the robot was being closely monitored by two technicians, one at a computer terminal, the other just feet away from the machine. Without warning, the robot lost control. Its limbs thrashed violently, it dragged its base, and in seconds, the scene devolved into chaos. Equipment was knocked over. The technicians scrambled to avoid injury, repositioning the crane to restrain the flailing robot. Fortunately, no one was seriously hurt, but the event set off a wave of panic online. Comments poured in comparing the footage to science fiction nightmares like Terminator and I, Robot. This was more than a malfunction, this was a warning. Understanding the robot. What is the Unitree H1? To understand the implications, we first need to look at the machine at the center of it all. The Unitree H1 is no prototype. It's Unitree Robotics' first full-size, general-purpose humanoid robot, one that can not only walk but run autonomously across complex terrain. Standing at 180 centimeters tall and weighing about 47 kilograms, the H1 is a technical marvel. It uses a high-performance powertrain system that provides extreme torque, speed, and agility, peaking at a record-setting 3.3 meters per second, with the potential to exceed 5 meters per second in future updates. What makes the H1 particularly advanced is its 360-degree depth perception. It's outfitted with a combination of 3D LiDAR and a depth camera, allowing real-time, high-precision scanning of its environment. This data powers its decision-making system, one that continuously evolves through over-the-air software updates. Unitree has since introduced the H1-2, a refined version with enhanced joint torque, expanded degrees of freedom, and stronger motors. The H1-2 weighs about 70 kilograms and includes 27 degrees of freedom, giving it even more human-like movement and flexibility. It also features the M107 joint motor, a powerhouse motor capable of delivering 360 Nm of torque at just 1.9 kilograms of weight, setting a new benchmark for torque-to-weight performance. These robots are built with industry-grade components, including high-load, high-precision bearings, and powerful onboard processors like Intel Core i7 or NVIDIA Jetson Orin NX. They are equipped to handle real-world environments, and they are being pitched as viable for logistics, assistance, research, and more. The safety problem no one can ignore. And yet, with all that power and capability comes a sobering question: how safe are humanoid robots, really? The May 1st incident isn't the first of its kind. Earlier this year, another Unitree robot reportedly malfunctioned during a public demonstration. And before that, a Tesla factory robot in Texas allegedly injured an engineer. These are not isolated anomalies, they are signals. The challenge with humanoid robotics is that they are becoming more capable than ever, but the systems meant to control and limit them are often playing catch-up. Modern robots rely heavily on machine learning and sensor fusion to interpret their surroundings. But machine learning is inherently unpredictable in edge cases, those rare situations where the system encounters something it wasn't trained for. That's when malfunctions occur. Most robots today do not have sufficient physical or software-based constraints to prevent dangerous behavior. If something goes wrong at the sensor or software level, it can trigger a chain reaction of uncontrolled motion. And when the robot weighs 70 kilograms and has the torque to lift or strike like a small car, that's a serious threat. Robots are here, but are we ready? The May 2025 Unitree H1 incident has forced the world to look harder at the realities of humanoid robotics. While these machines are incredible feats of engineering, their risks are no longer theoretical. As we race into a future where robots walk, talk, and work beside us, we must ensure they're not just fast, strong, or flexible, but also safe. Building safer robots isn't just a technical challenge, it's a moral one. Whether it's through stronger regulation, better design, or public pressure, the robotics industry must rise to meet it.